After use, the P.PSS solution should be returned to the fridge for storage. The filtered P.PSS solution is then allowed to warm to room temperature, ready for deposition on the ITO patterned substrates. To clean your substrates, carefully remove each substrate from its packaging. Be careful to handle the substrates by their sides. Don't touch the ITO coated areas. Load the substrates into the holder one by one, making sure each substrate is securely located. Prepare a clean glass beaker with boiling deionized water containing a little Helminix solution. Then place the beaker into an ultrasonic bath, fill with boiling deionized water and sonicate for 5 minutes. The ultrasonic bath causes rapid vibration to occur around the substrates, aiding the removal of particulates. After the 5-minute sonication, carefully remove the beaker. Be careful because the beaker might be hot. The substrates should now be dump rinsed in boiling deionized water. It is important to use boiling water to ensure no remaining Helminix solution is present on the substrates. Perform the dump rinse twice. After the dump rinse, make sure you change the deionized water. The substrates should then be cleaned in isopropyl alcohol. Replace the substrates in a polypropylene beaker having a tight-fitting lid. This lid prevents the IPA from evaporating during the sonication. The substrates are again placed into the ultrasonic bath. Make sure the DI water is close to boiling point. Sonicate the substrates for a further 5 minutes. Remove the IPA beaker from the bath and carefully remove the lid. The substrate should again be dump rinsed in fresh, boiling DI water. Perform the dump rinse twice to remove all the IPA solution from the substrates. Remove the substrates one by one from the holder and place them ITO side upwards on a clean room tissue. Hold the substrates with a pair of tweezers, being careful not to scratch the ITO. Use compressed nitrogen to blow away all the water. Carefully lift the substrate and place them on a hot plate, heated to approximately 120 degrees Celsius. To coat P.PSS onto the ITO, place the substrate into a spin coater and spin at 6000 RPM for 30 seconds. Take 35 microliters of your filtered P.PSS solution and dispense it onto the substrate, making sure the pipette tip does not touch the substrate. Once the substrate has finished spinning, remove it and place it back onto the hot plate. Once all the substrates have been coated with P.PSS, you are ready to spin your perovskite precursor ink. It is essential that humidity does not exceed 40% during the application of the perovskite ink. Use a dehumidifier to reduce lap humidity if necessary. The Acyla I101 perovskite precursor ink should be heated for 30 to 60 minutes at around 70 degrees Celsius prior to use, and held at that temperature during the whole deposition. Transfer the P.PSS coated substrate from the hot plate and place it onto the spin coater and spin it at 3000 RPM. Now dispense 30 microliters of the ink onto the substrate and continue spinning for 30 seconds. This will produce a bright yellow film. Place the substrate back onto the hot plate held at 90 degrees Celsius. After all substrates have been coated, use a dry, clean room swab and wipe the place where the cathode contact will go. This wiping removes the perovskite precursor from the surface. Now place the substrates back onto the hot plate and anneal for a further 90 to 120 minutes to fully convert the mixed halide perovskite precursor. After this time, all films should have turned from yellow to grey-brown. Once the perovskite films have been annealed, they can be transported to a nitrogen-filled glove box where they will be coated with a PCBM electron transport layer. Place the substrate in the spin coater, making sure it is secure. Take 20 microliters of a filtered PCBM solution and dispense onto your substrate at a spin speed of 1000 RPM for 30 seconds. Remove the coated substrate and place on a clean room tissue. Take a cotton swab dipped in a chlorobenzene solution and wipe the PCBM from both edges, making sure not to wipe the active area. After all the substrates have been coated with PCBM, load them into an evaporation mask. Make sure that the substrate is placed correctly with the ITO side facing downwards. Once all the substrates have been labeled and then placed in the evaporation mask, the top of the mask can be secured. Secure the lid with screws in the four corners. This will stop them moving around as they are transferred to the thermal evaporator. Place the evaporation mask into the vacuum chamber. Close the door and secure it before pumping the chamber down. A cathode is then evaporated onto the surface of the device. Here you can see the computer system that is used to control the deposition chamber and the evaporation process. After depositing the metal cathode, vent the vacuum chamber and remove the evaporation mask. Take care not to touch the active area of the devices. Open the evaporation mask and lift off the lid. To remove the substrate, flip the whole mask so the substrates are placed with their active side face upwards. Using a Pasteur pipette, drop a small quantity of UV curable epoxy on the center of the substrate. Place a glass cover slip on top of the substrate and press down to allow the epoxy to coat the device. Move the cover slip gently to help trapped air bubbles escape. Once all the cover slips have been placed in position, the substrates are ready to be placed under a UV lamp and cured for approximately 30 minutes. This encapsulates the devices and protects them from moisture and oxygen. The finished devices are now ready to be removed from the glove box. Each device is loaded and turned into a test rig and placed under the solar simulator. An aperture mask is used to restrict the active illuminated area. The efficiency of the devices are recorded by measuring a current voltage sweep as they are illuminated by the solar simulator. We routinely characterize the device open circuit voltage, short circuit current, fill factor and power conversion efficiency. Using the Oscilla I101 perovskite precursor ink, we routinely obtain power conversion efficiencies greater than 10%.